Okay, so welcome back to another one of these explanatory videos. We're still on exam 1 from 2015 fall semester, and we're on question number 12. It says, which of the following species valence electron experience the highest effective nuclear charge? And if you remember from class, the definition of the effective nuclear charge, let me just highlight it with purple line, equals to the Z, that's the effective nuclear charge, equals to the numbers of the protons of this particular atom minus the numbers of valence electrons. So this is the effective nuclear charge. Let me write it down. Effective uh, nuclear charge. And this is the numbers of protons, or just atomic number. And this is the core electrons, numbers of core electrons, maybe. Core electrons. And what is represent is that this I'll try to just do it with my razor. This thing over here, it actually means like the pulling force, this is the let me just try to do it with another color. The like this is the nucleus, and those are the like electrons on the outside, electrons on the outside, on the outside, on the outside. It's like the pulling force the valence electron experience, like uh, like the effective nuclear charge is exactly the pulling force it experience as it's in one of those electrons. So which makes this equation make sense, sort of probably. So it's like the protons in the middle minus the numbers of the core electrons, which kind of does the shielding effect, if you remember the shielding effect. The shielding effect. Maybe I draw a shield. I hope that's a good enough shield. Okay, that's the shielding effect of having those electrons. So for this particular question, let's take a look at all the choices. Um, so for choice number A, not number, for number A, for for A, it's the atomic number of carbon, which means the numbers of protons of the carbon is, I believe, 6, minus the numbers of core electrons, which is 2, and that gives us an 8. I'm sorry, that gives us an 4. It gives us an 4. And for this particular 4 over here, there's because the negative 4 over the 4 negative over here means this carbon atom is actually holding 4 extra electrons. So it's actually 4 effective nuclear charge towards 4 valence electron plus 4 additional electron, which gives us 8. So that's 4 electrons, 4 effective nuclear charge towards 8 electrons. ZF maybe. And for like just regular calcium, it's a 20 minus 18. As you can find these numbers on the, I believe, on the periodic table, and will give us a 2 on 2 electrons, which if you can find on the periodic table, I suppose I can get the periodic table somewhere over here. Let me try to see. Yeah, here we go. So you can see the calcium is over here, and it has 1, 2 valence electrons, and so it's the way to calculate the core electrons is you just use 20 to minus 18. Well, like I'm sorry, 20 minus 2. It's probably screwed up. Minus 2 will give us the 18th electron, which is the core electrons. I will not write out the entire word. Yeah, and so that's the core electrons. And there's a 20. Let me just use a different color. and this means there's 20. This atom actually holds 20 protons in its nucleus. I just clear this up for no reason. Oh yeah, I can do this with the arbitrary eraser over here. No, that won't. Okay, cool. And let's try to go back and see if that works. So that's how you get this number. And for this one, it's I believe a 7 minus, no, a 9. Oh, no, different color. The arbitrary eraser. Yeah, here we go. It's 9 minus 2 plus 9 minus 2, which gives us 7. And since it's holding one extra electron, so it's 7 effective nuclear charge towards 8 electrons. And for this, well, this is actually kind of weird for a potassium to have like a potassium ion. So let's think about this particular potassium ion. So we got the nucleus over here, and we got like the first valence shell, the first electron shell, the first the first level of the electrons, and the second layer of electrons. And it used to have like a third layers of electrons with 2 electrons on the outside, which was this over here was its valence shell, and these over here are its core. And because we lost this part during the probably during some kind of reaction, so now the second layer that used to be the core electron now become the valence electron, which gives us a total number of I think it's 2 8 2. So a total number of 2 electrons. Hold on a second. Yeah, I think so. Yeah. So that's 8 minus, what is the number of calcium? 19, I believe. Yeah. Minus 2, which gives us 17 towards 8 electrons. And sodium is kind of like the calcium on the top. It's man, I'm forgetting my chemistry. It's 11 minus 9, 10, I believe, which gives 1 towards 1 electron. Therefore, the calcium, uh, no, the potassium experienced the highest effective nuclear. The valence electrons of the potassium experience the highest effective nuclear charge. And we'll end here.